And like I said, so the objectives for this module, we'll talk about virtualization and networking. We'll talk a little bit about the cloud stack. I'm gonna let you work on your appropriate IP addressing. Most likely your IP addressing, and you'll see this when you start setting things up, they will give you the IP addressing that you're going to use. Not a lot of times where there's not a whole lot of times where you actually make any changes to that. You will need to work on learning the basic subnet calculations because there is a lab where you have to do some subnet calculations. It's not a huge deal. It's pretty straightforward, and but that's part of what we need to understand for this chapter. We will look at configuring network interfaces in the cloud, and we'll talk about segmentation configurations in AWS. We'll talk about routing in AWS. We'll talk about segmentation and routing in Azure. We'll talk about segmentation and routing in GCP. Those are going to be the big topics, and actually most of this page is what we'll talk about today. Okay. A couple of key terms that you need to be aware of. Cloud networking works at a logical level. So understand that for most everything that we're going to do, you will think of it as a physical configuration, but understand that it is purely software. Like the network configuration that you're dealing with is purely a software configuration, right? So we are dealing with software-defined networking. The idea of that is we're, first of all, is to separate the control plane. And what they mean by that, and there's a graphic coming up, but the graphic will show you that if you have a switch and a router, right, you would log into each one of those to manage that switch or the router. And when you separate the control plane, you log into a management console and you would then manage each of those individual devices. You're not actually having to go to the device and manage that device individually, okay? So we take that another level in cloud, and we take all the network functions and we virtualize all those. So your switch is virtual, your router's virtual, your firewall is virtual. None of those things are actually physical components within the system, right? You can think as though they're physical components and work with them as if they're physical components, but understand that they are not. They are simply software. Right? And this is what they're talking about by, we had a switch, a router, and a V-switch, and each one of those has its own control panel, right? And what we've done is now remove that panel from everything to manage it here, right? So this is a basic understanding of what software-defined networking is, and this is where a lot of networking is going nowadays into this software-defined world. Okay, even in Cisco, right? They're starting to require you to learn some Python and how to configure your network with programming, not specifically logging into the machine and programming the machine itself, but programming it outside, separate from the machine and sending the code to the machine, right? And this is just a picture that shows us this is a firewall within Azure, but understand that like this is not literally a hardware physical device that we're actually going to be logging into and checking out. This is a virtual version of that, okay? Then we get into those networking topics, and like I said, we're going to not cover, right? We're not going to go through all the bits and the bytes and all those kind of fun stuff today. What I do want to cover, though, is how networking works in the three primary cloud service providers, okay? Virtual private cloud. So the C, it stands for cloud. So in Azure, in AWS, when you create a VM, which we've already done, right? And in the process of creating a VM, you may be aware of it, you may not be aware of it, but in the background, that VM had a virtual network interface card. There was a virtual switch created and a virtual subnet created in the background. So it created a virtual private cloud network for you. We did not interact with that as part of that initial setting up of a VM. Going forward, you will start to interact with those things. And this chapter is kind of the idea is to kind of show you how this works. All right. So AWS calls it a virtual private cloud. Azure calls it a virtual network, and GCP calls it a virtual private cloud. All right. When you create, and this is what I was talking about a minute ago, when you create an instance in AWS, it automatically configures a default VPC. If you have VPCs and you want to add devices to different VPCs, then you would control where the which VPC it's going to be created in. Our original VM, we weren't worried about that, so we just created one and it created the default settings for us automatically. Okay. You can create new VPCs or use the non-default VPC already created. You can choose any of those options as you go. All right. So in the AWS world, we have these things known as regions. And what regions are geographic locations for the physical data centers. Okay. So I think if you looked early on, you may have been put in US East 2, you may have been in US East 1. You may have picked US West 1 or 2, which is Oregon. I think US East 1 is the Virginia location. That's their primary data center, AWS's primary data center, which is interesting since they're based in Seattle and they don't have a geographic zone in Seattle. But they have these things called regions, and there's more than 24 right now. I think they're actually probably up to closer to 36 at this point in time. Difference between the time when this thing was written and when it's when we're actually seeing it now. They are named for where they are physically in the world. So EU would be Europe and US would be US, right? So on and so forth. And you can choose where you put your VMs, and you would choose where you put your VMs based on a handful of different things, like, you know, maybe closer to where the customers are going to, or the end users are going to need it. Maybe in a region where the services you need are cheaper, or more readily available, or you have to put certain things like in certain countries because of privacy laws and other things like that. So like if you have EU customers, you'd probably have to fire up some stuff in the EU in order to maintain compliance with privacy laws, things like that. So you would pick kind of where you want them around the globe based on a whole bunch of different factors, right? You could also have them, you know, spread out all over the globe for redundancy. So you have, you know, if there's issues with either the East Coast of the United States, then, you know, our location in Brazil or a location in Europe can take over those kind of things. So it's kind of one of the coolest concepts about cloud is that you can pretty much fire up wherever they have, you know, resources available that match your needs, right? So pretty cool stuff. So regions, right, is their first kind of deal, and here's the region that they the big five in North America, right? So the US East, which is Virginia, US East 2, which is Ohio. There's a central region, which is actually in Canada. There's a west region in Oregon and a west region in Northern California. Okay, so those are the primary regions. They have a bunch of local locations now, and that's a different concept than what we're talking about at the moment. And I think they've added more since this was put together. Okay. In each region, you have a default region assigned to your account, and it's usually going to be based on how close it is to you physically. But then, like, you would choose different regions, like I said, for latency issues, available features, cost, redundancy. There's all kinds of things that you would pick why you would choose a different region. Okay. Within each of the regions, they have these things called availability zones. What an availability zone is an isolated data center. Okay, so this is a data center that's independent of other ones. So in let's go back 2 slides. So in US East North Virginia, right, there's 2 or more availability zones, right, or 2 or more independent data centers, right, buildings with their data centers in them. They have their own power, their own cooling, their own network infrastructure, their own connection to the internet, separate from all other regions, right? Each region has to have, in order to be a region, you have to have 2 or more availability zones. So everywhere where you have a region, there's at least 2 availability zones there, okay? And what's cool about those is you can set up your system to take advantage of and duplicate your information or duplicate your system on 2 different availability zones so that you have redundancy and high availability. And if a zone goes down, then you shouldn't, your others, at least you'd have to lose both zones at the same time, which is not likely. But that would give you some resiliency and redundancy. Okay, so pretty cool stuff there. When you're setting up networking, so this is I think we build, if you look over here, kind of previewing this, we're gonna build up our network slowly but surely, right? So, so in the US East Ohio region, there's 2 availability zones. There's an A and a B, okay? And then that region has internet connectivity, separate from all other regions, okay? That's the kind of the base underlying components. There's the region, this little gray box, grayish purple thing, and then inside of that region, there are 2 physical data centers, right? Creating 2 availability zones in the US East Ohio region, okay? When you create a VM, right, you'll get a default VPC, right? And it will be created in each region available to the user. So you'll get a VPC in whatever region you've chosen to create your VM. Each VPC is automatically assigned a /16 IP4 address range, right? VPCs will span all the availability zones in each region. Okay, DNS and DHCP options are initially set at the VPC level. Okay, so you're going to create a VPC. It's going to be a /16. It's going to span both of your availability zones within a region. Your DNS and DHCP will be assigned at the VPC level, right? And most of your resources must be associated to the VPC. So when you create resources, if you don't have a VPC, it creates the VPC for you. If you already have a VPC, it will ask you where in that VPC do you want this, or do you want to create another VPC, okay? What we've created at this point is this piece here. Now we took that original drawing from earlier, and you have your account, which is this green box. And inside of that, we have now set up this gray box, which is a VPC. And over here, we've been assigned 172.31.0.0/16, right? And that's been assigned to this VPC, and this VPC spans 2 availability zones. So we have infrastructure in both availability zones dedicated to our VPC, okay? So that's the first step of this process. We've got this virtual private network across 2 availability zones within the region that I've chosen to set up my system in. All right. And here they're just kind of showing us, right, carried over settings of subnet. So then you see right here, the subnet 172.31.0.0/16, and the VPC is named VPC-88 and something else. There's much stuff going on behind there. Okay, there's DHCP options are here. Your routing table is right there. Your access control list is right here, right, for this VPC. Okay, this is my VPC, your VPCs. This is my main VPC, and down here, all of the kind of the settings. My CIDR blocks, I can divide this up. I can do all kinds of things. So it's just like, you're given a /16, and then within that /16, you can start to break things up and make things happen. Okay. Pretty cool stuff. You can just edit it. You can edit the CIDRs here. You can set up your DHCP options, your DNS options, all from the actions button right above your VPC there. Okay. We're going to keep building this out. So within your VPC, you can create subnets. And when you create a subnet, the original subnet that you create will be a public subnet, meaning it has access to the internet. It will be a /20 from your /16, right? which gives you 4,096 addresses. AWS uses 5 of those. They reserve 5 of those. So you have 4,091 usable addresses in each of your subnets that you create from your VPC's default /16. Okay, you can create multiple subnets within each availability zone, and you can choose whether those subnets are public or private. And the difference between public and private is public is accessible to and from the internet, and private is you can manage them, but they don't have access to the internet. Okay, your subnets don't span AZs. Your VPC, your virtual private cloud, right? Your network space will span AZs. But if you set up subnets, each subnet will be in a single AZ unless you have it duplicated, okay? But by default, they're not, right? So you've got subnet 1, subnet 2, and you can see now we've got 31-0.00/20, 31-16/20, and then 3132/20 and 3148/20, okay? So the /20 is gonna break that, that next octet into segments of 16s. I've created, there's a public subnet. These have access to the internet. You can see that with the black line. And then if you create private subnets, right, these are like your internal networks, okay? They do not have access to the internet, okay? You can do some fancy stuff that will tunnel it through this public subnet. Always costs money, but it's doable. But if you're going to set up privates, you can see that they're different. So each one of these subnets, right, separate subnet from everything else, one subnet, each subnet can be in a single availability zone, okay? So you can also see that your VPC is this gray box here. This is my overall network, right, with this /16. And then I'm dividing it into smaller pieces to make them usable, and then deciding which availability zone they go to within my VPC. Okay. So from Amazon Web Services standpoint, right? We have now our VPC, we have public subnets and private subnets. Okay. You have to have an internet gateway in order to communicate with the internet, which the gateway is automatically there for your public subnets, okay? Your cloud-based resources provide connections between your internal private resources, public internet, so you can create routing tables that would allow you to pass traffic back and forth to certain things, right? It provides you a route to the internet. You can support both IP version 4 and IP version 6 traffic. You can build out a NAT, a network address translation service, which will act like a firewall. And this will actually interface, this creates an interface on your private network that gives you temporarily assigns you a public address through the gateway. Right? So there's all these configs that you can do. And these, again, we're just talking basic configs. This is gonna be the expanded out version. So we'll do this so you can see this a lot bigger. So now we have, here's our account, right? And that's sitting on top of this region. In the region, we have the 2 availability zones. Right? We created a VPC, which gives us our networking, right? Our overall networking. This is where I get the /16. I created, they created public subnets and private subnets. Okay. The internet gateway, which is automatically put together for you, is here. And then each subnet has its own routing table, and it's usually, they start out as a copy of the routing table on the internet gateway, and then you modify them from there. But these allow access, from here to here and from here to here and so on and so forth. Okay. If you created private subnets and you wanted to get them to the internet, you could create a NAT gateway, which then you can plumb through the public subnet to the internet through a NAT gateway. And then you would then at that point be assigning routing tables to each of your private subnets, right? This piece costs extra money, okay? But this is a configuration that shows you that we can take this bigger subnet, right? This big subnet piece here, and create it into, we can make smaller subnets, and then I can tie them together in any form or fashion. And these are the basic configurations: subnets, routing tables, internet gateway, right? NAT gateways, and VPCs. Those are the 5 basic components of networking on an Amazon Web Services system, okay? There's a whole lot of other things that we can add that we don't need to discuss at this point in time, but that's just the basic configuration to set up a network here. This one is this is more complicated than you need to get started, right? Because most of you are going to use a public subnet, a single one, in a single availability zone, and you'll use that for your VMs and things like that. You may want to set up a second one, and so they can route back and forth and kind of play with that kind of thing. But setting up, you know, private subnets with NAT gateways and 4 different routing tables, at this point, right? Just understanding that this is possible is sufficient for what we need to accomplish, right? Did I keep going? Gateways and route tables, right? So routing to the IG. So there's always going to be a default route. So these default routing tables will automatically, for the public subnets, there will automatically be a default route, right? And if you're not familiar with a default route is going to be the 0.0.0.0 subnet or a network address, and it's going to point to whatever your router is. In this case, your router is the internet gateway, okay? That's a typical setup. What that line means essentially is if I don't have any other rules for where to send the traffic that I'm looking at, I'm going to send it to the router and then let the router take care of what to do with it, okay? So there's always a default route set up for the VPC that goes to the IG, okay? A new subnet within the VPC is attached automatically to the IG unless it's a private subnet. And if you want the private subnet to connect to the internet, you would have to set up a routing table and a NAT. Actually, I think you set up the NAT gateway, and a routing table is automatically set up at that point. Fair enough? Trying to see if there's anything else here that we really haven't covered. You can modify the main tables. You can create your own route tables and have them supersede. Right? So you can control a lot of this after the fact if you wanted to. Each subnet has to be associated to a routing table. So for every subnet that you create, you have to have a routing table. It uses a default routing table, and then you can modify it on a per subnet basis. And here's, we were talking about that earlier. This one actually, this is the route table for this that's the route table. This is the VPC. And you can see down here, this is the local subnet, right? And then you've got your default route going to the internet gateway. There could be more down here, but this is a single, they only have one VPC in this account. So there's not routes to other VPCs. Okay, in your dashboard, you would find this under the VPC, Virtual Private Cloud, right? We're now, the earlier picture, we were on your VPCs. So this right here was the VPC, and it had other information about it. We've clicked down to route tables, and you can see that we're looking at the routing table associated to the VPC. Elastic IPs, right? Those are static IPs. So you can get static IPs down here. Static IPs cost you money. DHCP options, you can set up DHCP options for within each of your subnets. So all of your kind of network settings are going to be here in this virtual private cloud. Here's the NAT gateway, right? Your internet gateways. There's also egress only internet gateways, meaning you are allowed outbound traffic, but not inbound traffic. So lots of good stuff there. Excellent. I'm trying to see if there's anything we really haven't covered at this point, right? So this is a little bit about basics of routing, right? So I can go back here to show you the routing. So this is the route, so this is my default route. So there's only 2 routes in this table, okay? So if the destination address starts with 172.31, then it will just come back to the local switch. I'm gonna quote that, right? It's gonna be the local. It's basically telling you, hey, this is on my local network. So you would never you should never get something from the 172.31 network that would hit the router. The computer should know to send it directly to the other computer. Besides the point, if I have anything, like if I'm trying to go to, say, I want to go to 8.8.8.8.8, right? I'm going to go try to the Google DNS server. That wouldn't fit this. It doesn't match this pattern. So it would come down to the next line. The next line, it says this is the catch-all for everything. And if that 8.8.8.8 is going to match this because it's a catch-all, send it to this particular device, right? So it's going to it will say, what's my destination going to be? And based on the destination and which line matches, it will then send it to whatever I've set up as the target, right? It'll send that information to that next computer, and it'll allow it to go through, all right? So how does AWS apply those routes? Like I'm just talking about, routes applied to the traffic by matching the traffic to the most specific route applicable to that traffic, all right? So if you've taken Cisco classes before, and you've set up routing tables on Cisco devices, right, you would know that you have to have them in order, priority order, okay? Because it's going to start at the first one and then it's okay, that one's not good, let's go to the next one, that one doesn't match, next one, that one doesn't match, next one, that one matches, where do I go? Send it off, okay? And it's going to be the most specific version, right? So it's going to, as it goes through the Cisco routing table, it will send it to the first one that it matches, any that matches, whatever the case may be. With AWS, what it will do is, if you have something more specific, so for example, 172.31.0.0/16, and if I have a 132.31.0.0/20, right? The /20 would show me that anything that's 0 to 16 in that third octet is a more precise match. So that would be the one, that would be the item that I would use to send my data to, okay? So whereas normal routing tables, normal routing tables in the past, right, they had to be in the right order in order to, and it would go to the first one that it matched. Any portion of it would match. If it matched it, like /16 matches, but /20 is more precise, right? It would, if /16 was above the /20, it would go to the 16 route before it even got to the 20 route. But in AWS, it will go to the /20 route because it's more precise. I'm hoping that makes sense. Okay, NAT gateways. This is going to help you, and I've already talked about this as well, right? That's private subnets. They're going to allow you to communicate better, or allow you to communicate to the internet using NAT gateway. So it basically sets up a firewall for your private network, okay? Which is a lot of what you're going to end up doing. You're going to want to have a private network, which is your internal, kind of think about that as an internal network, like to your business. And then we always have physical firewalls usually on our networks. The NAT gateway is your virtual firewall for your private network that allows internet connectivity out, but not back in usually. Trying to think if there's anything else here. Multiple goals, right? So we're talking about different things that you can do with that. So understand that NAT gateways cost money to use, right? For the time that it's running and the amount of data processed over the connection. It also requires you to have an elastic IP address. You have to set up a public IP address for the NAT gateway. And then EC2 instances, right? Your compute instances incur data transfer charges, right? So The NAT gateway, this piece right here is where Amazon makes a lot of money, right? Because you set up these private networks and then trade data transferred across it. Costs money. It costs money while it's up and running, things like that. So just be aware that the NAT gateway is there's costs involved with the NAT gateway. Okay, I think you should be aware that there's costs involved with everything. Some things don't cost as much. Make sense? Okay, so now that we understand a little bit about how AWS operates, right? This picture here, right? We're going to take a look at Azure and how Azure, how they do things the same and how they do things differently, right? We're going to start off with right here. We don't use the term VPCs with Azure. We use the term VNets. Okay. There's lots of similarities. There are some differences. We're going to start with the geographic regions. Right. So they start with geographic regions similar to AWS. However, there are 54 plus Azure regions worldwide. With Azure, which I think it holds true with most everybody, most of these machines. Each region has different services. So some services are available in certain regions, some services aren't, okay? And the same with AWS and Google, costs will vary by region. And I mentioned it before, but data residency compliance standards will vary depending on the region. So wherever you are geographically in the world, your privacy settings and what you can do and how you protect the data is going to be different based on the geography. Okay. Geographic areas containing multiple Azure regions. Or we've already got that part. We're good. All right, next piece. Availability zones. Okay. So they do have availability zones, but they are not offered across all regions, right? So Azure has more regions, but they have less redundancy across those regions, right? So they have a whole bunch more, but they may have regions that don't even have what they would term an availability zone. They have data center components, but they're not completely, self-sufficient and all those kind of fun things. Okay. If you have a region that has an availability zone, so if you're using a region with availability zones, that means there's at least 3 availability zones in the region. Okay. So that's something different than Azure does. Azure says every region has to have 2 availability zones, right? 2 or more. Okay. Microsoft Azure is saying we have a bunch of regions, but not all regions have availability zones. However, if a region does have availability zones, there will be at least 3 availability zones in that region. Okay. An availability zone, just like Amazon, it's a separate data center, independent power, cooling, network infrastructure, all the bells and whistles, each one of them. Okay. So if you're working with Azure and you're using an availability zone, understand that you are in a region that has at least 3 availability zones available to you. Okay. So let's take a look at the US East Virginia. So this is Azure. Okay. The first thing that I see with this graphic is if we're going to have availability zones, there should be a third one out here. Okay. But we're going to go with, we're only seeing the first 2 availability zones. Understand there should be a third one. You have VNets and subnets in Azure. You have to have a subscription to contain your multiple VNets. So in AWS, you have an account, right? That green box that went around. In Azure, they call it a subscription. Okay. And your subscription can contain multiple VNets. So you can set up multiple VNets inside of your subscription. You must associate your VM in an account with one VNet. So you have to, if you have VMs, each VM has to be associated to one of your VNets. Your VNet can span multiple AZs within a region, which is, if you think back to AWS, your VNet automatically expanded across the regions. Your subnets couldn't. Okay. Each VNet contains one or more subnets. Subnets must use IP address space contained within the VNet, which is same as Azure or same as AWS. The subnets must have unique IP address range, right? These are all kind of standard networking things, right? IP address range cannot overlap, right? Subnets within the VNet can communicate with one another and the internet. So in Azure, they don't have a concept of public and private. Okay, so that's one of the big differences. Otherwise, a lot of this is the same, other than the name as well, right? The name is not right. It's not the same. So instead of being account, right, you have your account, the blue box. Inside of your account, you have subscriptions. Okay, so you can actually have multiple subscriptions underneath your account, and then within each of your subscriptions, you can have multiple VNets. Okay, we're just going to show you one so that we don't, get crazy here, but we have our account, which is the blue box. You have a subscription, which is the green box. And inside of that, you have your VNet, which can span multiple availability zones, right? And in this case, they've given us a CIDR of 10.0.0/24. Okay. So this is a /24 that they're going to give us. And from the /24, we should be able to subnet, all the way down into the very end of that. Inside of each of your availability zones, you can see here that they've subnetted from 24 down to 26. Okay, and I can get, so I've got subnet here, 0/26, and over here, 64/26. Okay, so I've got two subnets. Each one of them can handle, looks like 63, 62 end devices. Okay, and both of those subnets have access to the internet. Remember, we don't have the idea of a private subnet here in Azure. Okay, but you can also set up your routing tables as a NAT, right? So these can be and act like private subnets. They just have access to the internet. Okay. When you create your VNet, it automatically generates a routing table. The routing table enables communication between all resources within the VNet, regardless of the subnet. Okay, so what that means is these subnets can talk to each other, and these subnets can talk to the internet. And if I added other ones, they could all talk to each other as well. Okay. Your default system routes cannot change. Okay, however, you can create a routing table that overrides the default system settings. Okay, and the routing is based on destination IP address match to the address prefix. So it's going to match the subnet, or the subnet address. Okay, so even though it's automatically set where you have access, you can set up a routing table that cuts internet access or cuts access from other subnets on your VNet. Right? You can adjust your routing tables. Yeah, so they don't mess you up with the nickel and diming you for NAT. That's another. So one of the reasons, so that's one of the reasons why you would consider maybe Azure instead of AWS for that. Is you're not getting, you're not paying for those private private subnets being connected to the internet. I'm trying to see if there's anything else here that we haven't really covered yet. Nope, all those are fine. So here's what that looks like, right? So each of these now has a routing table attached to it that allows routes back and forth, routes up to the internet. Okay. And if you wanted to cut, right, your access from the internet down, then you use the routing table to block that traffic. Right? So, and that's it. That's the differences. There's not a whole lot of differences. There's no private, right? Because there's no private, you don't need NAT gateways. You would use your routing tables to do that. You do have to have that subscription inside of your account, and everything is kind of built inside of that. You could create multiple VNets and get more IP addresses, and you can create subnets within each of those. Your VNets can span availability zones. You can modify the default routing tables that are set up for you automatically. Those can be modified, and and to make it work the way you need to work. Excellent. All right, and now we're down to GCP. Okay, so we call them VPC zones and subnets, so real similar to AWS. A couple things that are different, right? A VPC in Google spans all regions globally. Right? So all regions globally is your VPC is everywhere, right? There's no IP range assigned to it. CIDR range is defined at the subnet level. So when you set up a VPC, you don't get a subnet that you have to you don't get a network that you have to subnet, right? When you create the subnets, you get addresses there, and they all are different from all your other ones. And they can be all over the map. You can have a 10, you can have a 172, you can have a 192, and so on and so forth, right? You can only support IP version 6 to external resources, but internally within the Google platform, it has to be IP version 4. Not sure why they're hamstringing themselves with that, but that's the way it is. There are 20 regions worldwide for Google. Most regions have at least 3 zones. The zones, again, availability zones, independent power, cooling, networking, and control planes. GPC, VPCs span regions as well as zones, right? So your VPCs will span, you can have them go across regions, right? Backing up resources and applications around the globe can be accomplished without leaving Google's private infrastructure, which is pretty cool. And what they mean by that is I can actually set up a system where, let's say, maybe my region is, US West in Oregon, and I want to back up to a region in Europe, right? Because I have these 2 regions, I have these 2 VPCs set up on the Google platform. If I want to transfer data from United States to Europe, there's no cost because I never leave the Google network, right? So one of the kind of huge advantages of Google's platform is this idea that you can transfer data amongst your systems. Once the data is on their network, transferring it between the networks, as long as it doesn't go to an outside source, right, doesn't cost you any money, okay? Which is pretty cool. VMs in one region can communicate with VMs in another region. So I can have these communicate directly without going onto a public internet. This is all internal to Google's network. So just imagine that, right? Google has their own private network that spans the globe, and they can outsource that network to hundreds of thousands of customers and handle it no problem, right? Kind of scary how big their networks are, right? When you're choosing regions and zones, right? So again, keeping your resources geographically close to your end users, that's going to be your primary, right? That's going to reduce latency. That's going to make sure that you have minimal delay, that kind of thing. Again, what services are available in that particular region. If that region doesn't have services you need, then you can't use that region. Costs, right? So different regions have different costs. And then a lot of regions, and you'll start to see this as you start to look at maybe more high-end servers, some regions don't have the hardware that you want to use in that region because they physically haven't racked and stacked that type of hardware. So you got to be aware of that as well. Okay. So whoops, here's the picture for Google. I like the fact that they've actually shown you, like, we've got 2 different regions now. We're using US Central and Europe West, right? There's 2 zones here and a single zone over here, right? So for the Google platform, we're kind of just showing this global setup versus an individual region setup, right? When you set up your VPC, it spans multiple regions, right? VPC creation in auto mode creates a subnet in each region for that VPC, so it automatically creates subnets for you. When the new region is added, auto mode adds a new subnet for the VPC in that region as well, and it uses a pre-configured IP addresses ranges, so you can actually set up what IP address range you want on the newer subnets. You can choose, in some cases, you can choose where the subnet is located or whether to create any subnets at all. Okay, so you got some options. So then we're going to fill this out really fast. Like, so whammo, we set up subnets, right? So we set up a VPC, it spans across multiple regions, and then it automatically created subnets within each of our availability zones. There may be NAT charges, I'm not sure. We haven't got that far. Right? There's cloud routes.
I was just thinking, I think I answered my own question, because you said if it doesn't leave Google, then so no, there shouldn't be any NAT charges.
If it doesn't leave Google, there's no NAT charges, right? But if you, as soon as it leave, some things you get charged on leave, most of it's on when people download things. I don't think ingress even costs. Like, you can send a bunch of data to it, you're not paying for that, but then when you pull the data out, that's when you pay.
Right. Okay, cool.
So there's a model. I mean, every single one of these structures is designed for them to make income, right? So don't get it wrong that, hey, this is, because you can transfer data for free, it means there's no other, that everything is free. It's like, well, not really, right?
So you're paying for the machines being up, and
paying for the machines, paying for the subnets, paying for the right. So on Google, right, we've got the instances, right, connected to cloud routes, which is your routing for the entire VPC. And we've created, 3 different subnets, and they gave us /20s, and you can see they're all different, right? And they can just randomly give you stuff as long as there's available IP addresses within your within each of these. Like, so this is a 128/20. I can do all kinds of other numbers, right? And get all kinds of subnets, right? So you're not limited. It's very open what you can do. Okay. Does that make sense? So now, right, so Google has an account, right? They set up a VPC, it spans multiple regions, it sets up subnets automatically within each availability zone within your region, within your VPC. If you fire up instances, each instance has access to cloud routes. I think this is interesting right here. We don't have anything in the subnet, so there's no connection, right? Until you put something in that subnet, it doesn't need to make a connection, okay? Fair enough. So there are some global advantages: distant region accessibility from on-prem resources through a single VPC connection. So I can connect to, say, the local, let's say Google. I thought Google had something in, I want to say they have something in Austin or San Antonio. Like, so that can be my closest region. And as soon as I'm there, I can then, using routing on my VPCs, get to, say, a region in Brazil or China or Europe, right? And I say those because I've seen a demonstration of Google's cloud platform. There's a company called PyTop that I really like. They create Raspberry Pi based computing systems. And when we went to Pi Wars 3 years ago, we got to go and meet with the engineers, and they showed us their Google cloud platform. This is a company who manufactures, laptops based on Raspberry Pis, and they didn't have a single server on site. Everything was in the Google Cloud, right? They had a site in Europe, they had a site in Brazil, they had a site in China. They used Kubernetes and containers, and it was really neat to see them upgrade 20 different servers in about 30 minutes while we were watching. And it was neat because they said, okay, these servers need to be updated, go ahead and start. And it would actually, you could see it migrate from Brazil to China and Brazil to Europe and all over. It would migrate the services out to other locations, no cost, right? Because it's internal to their network. It did the updates on the VMs that were in place, and then it fired up those VMs, and then it took down the VMs that were that had been moved to other regions, and the new one took back over. It was just really neat to see, like, how dynamic and how quick and how flexible you can be with this global aspects of being able to avoid the expenses of all those migrations and moves because it never left the network, right? It's pretty cool stuff. You pay for fees on egress, right? So anything going out of the VPC, it should be VPC, out to the, back to, a user or you, your network or your whatever. So that's where they charge you there, is when data leaves the network, you get charged, okay? And then routes. So routes are applied at the VPC level. And I think I pointed that out a second ago, right? The routes are here. They are not on a per VPC base or per subnet basis. They are on the VPC as a whole, okay? There's the different types, the system generated ones that are automatic, and then you can customize them, right? VPCs have access to the internet. They're managed by a default route. You can prevent internet traffic from the VPC, prevent all internet traffic between a VPC and the internet, right? Delete the default route connecting to the default. So, but that would also prevent all of your subnets from connecting to the internet, okay? What you could do is you could set up routes where you don't give a route, an internet-based route from a particular subnet to the internet, okay? So like each one of them does it just enough different that you have to be kind of familiar with each of the pieces or each of the different services to do that with, okay?